present about production of ammonia. So what is ammonia? Ammonia is a compound of nitrogen and hydrogen with a formula and history. Nowadays, ammonia is commonly produced in chemical industry. At about 80%, ammonia produced by industry is used in agriculture as a fertilizer. Ammonia is produced in a process known as a dehydration process, which is this process, the hydrogen and nitrogen will react in the presence of ion catalyst in the form of ammonia. We know that the ammonia is a corrosive chemical. The higher concentration of ammonia will affect to us, such as burning of the nose, throat, and skin burn. It also can cause eye damage.
Hi, my name is Muhammad Lukman bin Ismail. I will be presenting about process flow for production of ammonia. Our feedstock is natural gas. As we know, natural gas contain sulfur. The first process, we need to remove sulfur by using hydrogen. In the first question, hydrogen react with natural gas that contains sulfur and will be produce natural gas without sulfur plus hydrogen sulfide. We need to remove sulfur because sulfur can deactivate the catalyst for the next step. For second reaction, hydrogen sulfide will flow through the zinc oxide catalyst and will be produce zinc, sulfide and H2O. We need to flow the hydrogen sulfide through the zinc oxide catalyst because we need to remove sulfur from the hydrogen, and then hydrogen will become H2O, water, and the catalyst cannot use again. After the second process, we got the hydrogen gas. Then we move to the final process. From the second process, we got the hydrogen, but that hydrogen is not pure. This is final step. This final step will purify the hydrogen. Okay, in the hydrogen that contain the residue, that CO and CO2. After the final of purify the hydrogen, we move to the production of ammonia. This is a question that production of ammonia by using Haber-Bosch process. In this reaction, we use the iron as a catalyst. Okay, for the nitrogen and hydrogen, that in volume ratio 1/3. The nitrogen will be 1, the hydrogen will be 3. In this reaction, we will use the temperature 400 degrees C until 450 degrees C and the pressure in 200 atm. By using all the parameter, that will produce the NH3, that is ammonia. That's all of the process flow. Thank you.
The production of this important basic chemical still has its firm place within BASF's chemistry Verbund. To combine the two starting materials, nitrogen and hydrogen, to produce ammonia, the bonds in the diatomic nitrogen molecule have to be broken. Under high pressures of more than 150 bar and temperatures above 400 degrees centigrade, nitrogen adsorbs onto an iron-based catalyst and is split up into atoms. Hydrogen can now be adsorbed and ammonia is produced. The catalyst itself remains unchanged. This reaction generates heat, and therefore the reacting hot gas in the ammonia reactor is cooled with a supply of cold gas. This is achieved with a sophisticated flow system of synthesis gas based on the heat exchange principle. In this way, the so-called equilibrium reaction can be prevented, in which the ammonia tends to decompose again to its constituent elements. The ammonia is collected as a liquid and stored in tanks. The remaining synthesis gas is returned to the reactor and forms more ammonia. An important precondition for ammonia synthesis is the efficient production of pure hydrogen. In several process steps, this precedes the actual ammonia synthesis. In the primary reformer, first the natural gas methane is heated together with steam to about 800 degrees centigrade and is thereby converted into a mixture of carbon monoxide, carbon dioxide, and hydrogen. In the downstream secondary reformer, air is then added and the remaining methane gas is converted at above 1000 degrees centigrade by means of catalysts, and nitrogen is added. Since especially carbon monoxide but also carbon dioxide would damage the iron catalyst used in the ammonia synthesis, they have to be separated off. Carbon monoxide is converted into carbon dioxide in a two-stage process using special catalysts. The carbon dioxide can be removed by a chemical scrubbing process. What remains is the pure synthesis gas consisting of 3 parts of hydrogen and 1 part of nitrogen, which can now be transferred to the actual ammonia reactor. A good 3/4 of the global output of ammonia goes into fertilizer production, while the remainder is used for technical products.
I will be presenting about environmental effect from industry. As we know, the ammonia will affect to our environmental. First is the water. When the ammonia spill in the water, it will cause the harmful to the toxin. Next is air and soil. The ammonia gas will vaporize and cause the acid rain. When the acid rain drops into the soil will become acidic. And excessive ammonia will cause leaching to a water body. Next is to human. It will cause the burning in throat, eyes, nose, and respiratory. Next will be the blindness, lung damage, breathing is difficult, and damage cell body. The ammonia also will cause the death of human. Next is the livestock. The ammonia gas will cause the toxin to livestock as the livestock breathe the gas. Lastly is the plant. The ammonia will cause the sulfur yield loss and burn the leaf, which affects the crops, but the roots will not be affected.
And I will be talking about application and uses of ammonia. So the first application of ammonia is as a fertilizer. Globally, 88% of ammonia was used as fertilizer, other as its salts, solutions, and also anhydrous. So when ammonia is applied to soil, it helps to provide nutrients to increase yield of crops such as maize and wheat. And next is ammonia as a cleaning agent. Household cleaning agents uses ammonia and also water, or namely as ammonium hydroxide, as a general purpose cleaner for many surfaces. It is because ammonia results in a relatively streak-free shine. One of its most common uses is to clean glass, porcelain, and also stainless steel. Ammonia also frequently used for cleaning ovens and soaking items to loosen back on grimes. That's all.